So we've got a broken dishwasher. We're trying to figure out which plumber to hire. We've got one plumber that charges $36 an hour for the labor, and then also $50 for the service call. And then we've got a second plumber that charges $35 for the service call, which is less, but their per hour charge is a little bit more at $39 per hour. So we needed to decide which plumber we would choose. So what we did is we took the information here and we created a double table of values. So we looked at how much each plumber would cost for various number of hours. We took those points and plotted them on a graph and saw that they intersected at the point 5 to 30 in the table of values, and they also crossed over at the point 5 to 30 on the graph. So from there, we can make some conclusions. We could see that below the point 5 to 30, the plumber number 2 was the cheaper option. So if I need less than 5 hours of work, I would choose plumber 2. At 5 hours, it doesn't matter which one we choose because the cost is going to be the same for both, so we're good to go. And then after 5 hours, for any service call that would be longer than 5 hours, I can see that plumber number 1, the green line here, would be the cheaper option. So if I need more than 5 hours of work, I would definitely choose plumber 1. So what we can do now is we can take this same scenario and we can solve it algebraically. So the first thing that we would need to do is we would need to create our two linear relationships. So for plumber 1, the rate of change was $36 per hour. The initial value is 50. So I know that the cost would be equal to 36H plus 50. So that's where we had our Y equals the rate of change times your X plus your initial value. For plumber number 2, our rate of change was $39 per hour. Our initial value was 35. So if we plug those into our Y equals rate of change X plus the initial value, we can see that C is equal to 39 times H plus 35. So we have two linear relationships that model each scenario. We want to know when will the cost be the same. So I know that this cost is equal to this. I know that this cost is equal to this. So if we want to know when the costs are the same, I'm going to set this one equal to this one. So I'm going to set 36H plus 50 equal to 39H plus 35. So when are those two values the same? So what we've done is we've created an equation. We've got a variable on both sides. If we can get the variables onto one side and then solve for that variable, then we can figure out what the number of hours would be for which the cost would be the same. So I've got 36H plus 50 equals 39H plus 35. From our work with solving equations, I know that if I don't want an H on the right side of the equation, I've got 39 of them here. So to get rid of them, I'm going to subtract 39 H's from this side. I'm also going to subtract 39 H's from this side. So now I have 36 H's minus 39 H's, which is negative 3 H's. I still have my 50, so I'm going to rewrite that. I still have my equal sign, so I'm going to rewrite that. And I still have my 35, so I'm going to rewrite that. And you'll notice that this has gotten rid of the H's on the right side, which is what I wanted to happen. I want to get the H by itself now. I've turned it into a two-step equation to solve, which is great. So I need to get rid of my 50 and my negative 3. I'm going to start off with my 50. I have plus 50, so to get rid of it, I'm going to subtract 50 from both sides. I'm left with negative 3H. 50 minus 50 goes to 0. I still have my equal sign, and 35 minus 50 is negative 15. So I have negative 3H's equals negative 15. I want to get rid of my negative 3 in front of the H, so I'm going to divide this side by negative 3, which means I also have to divide this side by negative 3. Negative 15 divided by negative 3 is 5. So the number of hours would be 5. Okay, which I believe, if we look back at our last representation, we saw that the costs were in fact the same at 5 hours. So we can see it in our table of values. We can see it in our graph. And now we have just proven it algebraically by solving that equation. So at this point, we want to just figure out what the costs actually are at 5 hours, and we can double check to see if this answer is correct. So if I plug 5 hours in for plumber 1, I would have 36 times 5 hours plus the initial service call of $50. That works out to be a cost of $230. For plumber number 2, I'm going to have $39 an hour for 5 hours, so 39 times 5, plus the service call of $35, which also equals $230. So we can see that at 5 hours, sure enough, the costs are both $230, which again is what we saw here. 5 hours, $230, 5 hours, $230. So it's all matching up, all 3 representations. So now, as always, we want to finish with a conclusion. So if I need a plumber for less than 5 hours, I'm going to choose plumber 2 because plumber 2 has the lower initial value. So I know that at the beginning, it's going to be a lower cost. If I need it for exactly 5 hours, then I'm going to choose, it doesn't matter which one I choose because they both cost $230, so it doesn't matter. And if I need the plumber for more than 5 hours, I know that it starts plumber 2 cheaper, crosses over, plumber 1 then becomes the cheaper option because its rate of change is lower, so it's going to be a less steep line. So I've got my 3-part conclusion summarizing what I found when I solved that system algebraically.